Hello friends, today we are going to do LeetCode problem 700, search in a binary search tree. Now here we're given the root of a binary search tree and an integer val. So that is our input. What we need to do is we have to find the node in this binary search tree such that the node's value is equal to val and return the subtree rooted with that node. If no such node exists, then we simply return null. Now, we all know what a binary search tree is. A binary search tree is a tree such that all values to the left of this particular node are less than it. All values to the right of this particular node are greater than it. And this applies to any subtrees within this. So if you take this case, this value is less than 2, 3 is greater than 2, but then all values in this subtree are less than 4. So now if you go back to the whiteboard, so now what we're given out here is a root out here and this particular tree. Now supposing our value that we're supposed to find is 2. So what we can do is we can take advantage of the property that the nodes are in a binary search tree so that is they are ordered in a way. So if the value is 2, then I know that value of 2 is going to be in the left subtree as 2 is less than 4. So I directly go here and I find the node. Now the value is, say for example, 1. 1 is less than 4. So I know that 1 lies in this subtree. I go here. I know 1 is less than 2. So I go here and I return this particular node. Similarly, the value was 7. I know it's in the right subtree because 7 is greater than 4. So I go here, value comes out. And if I get a value of 5, then I simply go to the right subtree. Since 5 is greater than 4, there is no 5 here, and then there are no leaves here, or there are no children on this particular node. So I simply return a null. So now that we've done our analysis, let's go and write the code. Sorry. So now what I'm going to do is I'm going to define a search function. I'm just going to take two values, root and val. For now, I'm just going to give it pass. What I'll do is I will be returning the search, whatever the results of search are. Now, I will do this in an iterative fashion. So what I do is I first assign the value of current to root, and while current is not none, in case current.val is equal to the value of val, then I found my node in the binary search tree, and I simply return the current node. Else current.val is less than val, then I need to go to the right. So I say current is equal to current.right. Else current.val is greater than val, then I need to go left. And now once I come out, in case the node is not found, then I simply return a none. So going back to the whiteboard, I have a root here. Let me try with another pen. I have a root node here. I assign the value of current. My value is 2 that I have to search. 2 is less than 4. So I go to the left subtree and I found my node and I simply return that. If the value of val was say 3, this is the root. I assign the value of current here. 3 is less than 4. I go here. 3 is greater than 2, so I go to the right subtree. I find it and return. Now let me try this problem with a few test cases. So this is one test case where we are given this particular subtree or this particular tree, and we're trying to find a value of 2. If I run it, I get the root trees which is rooted at 2. If I put in a value of 3 and run this, I get 3 itself. There is no subtree underneath that. If I put in a value of 4, I should get the whole tree, which I do. If I put the value of 7, I get 7. There is no children below 7. And if I put a value of 5, I get empty because the node 5 is not present. So I'm going to submit this. And as you see, the results have been accepted. Now, the time complexity for this particular problem is going to be height of the tree. So imagine we have a left skewed or a right skewed tree like this, and we have to try to find the value of 1 out here. So we'll have to traverse this all the nodes in this particular tree. So we have to go to the height, go through the entire height of the tree. So your time complexity is going to be the height, and your space complexity is going to be O of 1. So thank you.